Welcome back to 5-Minute Chemistry. Today we are talking about polyatomic ions and formal charges. So what is a polyatomic ion? Previously we discussed molecules, which are groups of atoms that are bound together by covalent bonds which do not have a charge. Well, polyatomic ion is basically the same but also has a non-zero charge, and in some contexts, some people, when they talk about molecules, they will also include polyatomic ions. There is also a concept called molecular ions, which can be derived from molecules by taking away an electron from a molecule. So similarly how you derive like metal cations from metal atoms, you can also derive molecular ions from molecules by taking away an electron, but the category of polyatomic ions is a bit wider. Polyatomic ions are, as their name suggests, ions. So they are charged particles, which means they do not exist by themselves. A positively charged ion will always want to be together with a negatively charged ion, and the negatively charged ion wants to be with a positively charged ion. So polyatomic ions will exist in ionic solids where cations and anions are bound together by the ionic bonds. So widely known polyatomic anions are, for example, carbonate anion, which is CO3 2-, and the nitrate anion, which is NO3-, and then we also have sulfate anions, which are SO4 2-, and for cations, the most well-known is the NH4+, the ammonium ion cation. So these can form ionic solids either with each other or with just regular monoatomic ions. So in that case, what we will have is an ionic solid in which there are covalent bonds inside the polyatomic ions and then ionic bonds amongst the different ions. So let's take a look at the electronic structure, the Lewis structure of one of these polyatomic ions, the nitrate ion, NO3-. So first we need to count the valence electrons. So here nitrogen has 5 valence electrons, oxygen has 6 valence electrons, and because this polyatomic ion has a -1, a negative charge, we also have to add an electron, which will cause that -1 charge. So in total we have 5 plus 3 times 6 plus 1, which is 24 valence electrons. Okay, so let's write the elements and draw the bonds between them. So nitrogen is the central atom here, which is bound to the 3 oxygen atoms. And we should also draw this big bracket here to show that this whole thing is an ion, and then draw the negative charge in the top right corner of this bracket. The next step will be to fill the octets of the non-central atoms. So all of these oxygen atoms, they have 2 electrons in the single bond, and they need 6 more. So let's give them 6 more electrons. And now we should give the remaining electrons to the central atom, the nitrogen, but no electrons remain. We used up all the 24. So as a last step to rectify the nitrogen atom, which does not have the octet structure yet, we move an electron pair from one of the oxygen atoms to the bond here to form a double bond. And now we have the octet for everyone. So the oxygen atoms either have 6 non-bonding electrons with 1 single bond, which is 8 electrons, or 4 non-bonding electrons with a double bond, which is also 8 electrons, and the nitrogen in the middle has 2 single bonds and 1 double bond, which is 2 plus 2 plus 4, 8 electrons. So every atom has the octet structure. Now that we verified that, let's take another look at this structure and let's discuss formal charges. But before we go into formal charges and what they mean, let's get like a overview of what the Lewis structure is and what the goal of the Lewis structure is. So we have to keep in mind that the Lewis structure is not intended to be used as an exact description of the distribution of the electrons in molecules and polyatomic ions. The main goal of the Lewis structure is to give us sufficient information about molecules and polyatomic ions, while it is also easy to draw on paper and very easy to understand once written down on paper. The exact distribution of the electrons inside these polyatomic structures is, given by quantum mechanics. That is not something that is easy to draw by hand. So we have to keep in mind that the Lewis structures are very limited, but are still very useful. tools. And the formal charges is one of the tools we can use to get some information out of the Lewis structures, and we can use formal charges also to draw better Lewis structures. So formal charge is basically defined that if we pick apart this molecule or polyatomic ion by breaking all the bonds equally. So if a bond is a single bond and has 2 electrons, we will break this bond by giving one of the electrons to one of the atoms and the other electron to the other atom it is connected to. And then we will take a look whether either atom gained or lost electrons by drawing this Lewis structure. So first we will take a look at the oxygen in the right hand side, and oxygen has 6 valence electrons in an atomic form, and here in this polyatomic ion it also has 6 electrons, so it did not gain or lose any electrons, so its formal charge will be 0. Next, the other 2 oxygen atoms, they all have 7 electrons instead of the 6 that they have in their neutral forms. So both of these oxygen atoms gained 1 electron. So both of them will have a formal charge of -1. Next, we'll take a look at the nitrogen. So nitrogen originally has 5 valence electrons coming from the group 15, but in this polyatomic ion it only has 4 electrons. So the nitrogen has lost an electron when we drew this Lewis structure, which means that the nitrogen's formal charge will be +1 here. And if you add up all the formal charges of the atoms, which is -1, +1, -1, then you will end up with -1, and you should always end up with the charge of the polyatomic ion. So if you are in a molecule, you should always end up with 0 if you end up with the formal charges. If you are in a polyatomic ion, you will end up with the charge of the polyatomic ion. Okay, this is it for today, and I will see you tomorrow.